CIT 1122, this is instructional video for Packet Tracer 3.1.4. This particular packet tracer is going to show you how broadcast domains work within the concept of VLANs. If we look at the topology, it's a little bit wacky and it's not standard, and I would not ask you to follow this ever. But let's take this apart a little bit. So if we look at what we have here, we have three separate VLANs. Now, any interface that's connected to a switch can be set up for VLAN, right? So the interfaces for PCs 16 through 23 have all been configured to be access ports, and they are supporting VLAN 20. And once you do a switch port mode, switch port access VLAN 20 on an interface, you can't really set it up for anything else. So a switch port interface can only be set up for a single VLAN. So that's the first thing. So all of these interfaces here that support PC 16 through 23, those interfaces are all set for VLAN 20. Now down here between PC 0 and PC 7, these 8 devices, all of these interfaces are set up for VLAN 30. And then the PCs 8 through PC 15, these PCs, all the interfaces that are on the switch that are connected to these are set up for VLAN 10. Now, if you look at the way they did the IP address, and I can't not specify this because I don't think it's set up right. So the thing is, if there was no VLANs set on these switch interfaces for VLAN 20 or VLAN 30, if you look at the space that's being used, the addressable space, down here for VLAN 30 using 192.168.1.1 through 8/27. Now, if you expand that and you think about what's the size of that network, that's going to be any address that's going to be anything between 192.168.1.0 and 31 is in the same subnet. Okay, and that would be generally when you set up a VLAN, you tie it to a particular subnet. You do not do what they did here, which is overlap subnets with VLAN. So if we look at VLAN 20 is really kind of a little bit higher than halfway and a little bit more. For these 8 devices, they're in the same subnet as VLAN 30. So VLAN 20 is in the same subnet as VLAN 30, and it's generally a no-no. Generally, you don't want to do that. I only bring it up because if you're doing this lab on your own and you're looking through the way they set this up, you got to be going, wait a minute, what? I think that I learned. So think of it this way. Just do this from when you think about VLANs. One VLAN equals one broadcast domain equals one subnet. Do not do what they did in this video, which is overlap VLANs and subnets. You would never do this in real life. And the reason for it is if you had to connect it into a router and they both needed default gateways, you wouldn't be able to do inter-VLAN routing with this setup because one of these VLANs wouldn't have the gateway within their subnet. It just wouldn't be there, and you'd have to you would have so many problems going forward with what has been addressed here that it would be crazy town. Anyway, let's go back into what they do want us to see here. And all they want to do is simulate what a broadcast is. So what we're going to do is we're going to send a ping message from PC 0 to I think PC 7 or somewhere down here. And we're going to do it in simulation mode. And you're going to see that only the devices across the bottom of the system that are all set for VLAN 30 are going to receive that broadcast domain, okay? Or going to receive that broadcast message because they're in the same broadcast domain because they're all in the same VLAN. They've all been set for the same VLAN. All right, so let's go ahead and do that, and then we'll look at the configuration of the switch, and then we'll call it a day, all right? All right, so PC 0, going to go over to PC 0. We're going to click on Command. And I got some stuff in there already. Let's just go ahead and do this. Let's start with ipconfig just for fun. And we can see that our address is 192.168.1.1. And our subnet mask is a /27, which is 255.224, which means anything between 1 and 31, 0 and 30, 31, 1 and 30, usably are in the same subnet. Great. So they want us to ping 192.168.1.8. Okay. Ping 192.168.1.8. And it works. Okay, great. So 8. All right, so device that's sitting at 8 is not only in the same subnet as PC0, but it's also in the same VLAN. Okay, great. All right, so if we go into simulation mode, we can watch that action. So let's close that out, and let's click on simulation. And then from here, they want us to click on edit filters for ICMP, so ping messages specifically, and that is set up. And then the next thing they want us to do is hit the create complex button here, and the little envelope appears, and we're putting it on PC0. So we click here, and another box opens up. Now they're saying, let's just send a full-on broadcast message. Now here's another thing that you're just not, I mean, you're really just not going to do this. You're not going to send a ping out to the broadcast address. That's just generally, it's not something you would do. But the point is this, is if you did send a ping out to the broadcast address to all addresses, that it would go to all the devices in the same range, in the same subnet, in the same VLAN. So hit the sequence number for 1, hit the one-time shot for time for 0, create PDU, and then we hit the forward button, and it fires off. And it hits the switch. Now the switch can send it anywhere it wants. Anything that's in the same broadcast domain is going to get this, and look at that, it goes to all the other PCs. Oh, fantastic. And then a few at a time, they start to send them back, and everything starts coming back over to PC0, and all is well in the world. So hopefully that made a little bit of sense as we went through that. And then it says, you can go ahead and repeat this with PC8 and PC16. You can do that on your own. And then they give you some reflection questions down here. Let's kind of go through some of these. If a PC in VLAN 10 sends a broadcast message, which devices receive it? Only other devices in VLAN 10 would receive that broadcast message because they would be in the same VLAN and the same broadcast domain. So we're making a very strong case towards tying those two things together. VLAN 20, same deal. Other devices that are in VLAN 20. VLAN 30, same deal. Only devices that would be in VLAN 30 would receive that. What happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 30? And the answer is, it doesn't get there. So if I wanted to send a message to, let me go ahead and close this for instance. If I wanted to send a message from this PC, right? We just sent one from one device to another device in the same subnet and in the same VLAN, and it totally worked. So 1 to 8 worked, and I think 8 is actually device 7. So yay, good, that one worked. Now, if we look at going to VLAN, like a different VLAN, like PC8 over here is 192.168.1.37. If we try to ping that, ping 192.168.1.37, and we try that, that's going to fail. That's going to fail because for two reasons, right? Number one, our address is in a different subnet than the destination. And our default gateway value is set at all zeros. So we have no way of getting off of our network. If we have no way of getting off of our network, there's no way we can get to a device that's in a different network. So this game is over before it even starts, right? So that's just not going to fly. Now, let's look the other way. Let's take the what I think is a misconfiguration on the way they set this up, but we're gonna make it a benefit for our purposes. I'm going to Control-C that because it's still waiting to figure it out. If we want to go from PC0 to, say, PC19. So PC19's IP address is 192.168.1.21. Okay. That's in the same subnet as 192.168.1.1. However, the configuration in this switch says that they're in different VLANs. So even though they're in the same subnet, they can't ping each other because they are configured in different VLANs. And the switch is only going to create broadcast domains for devices that are in the same VLAN, right? So let's try that. So we said PC18, I think, is where we were there. I just forgot what address I'm just trying to ping. 1.22. So let's do, I think it was 1.21, but who cares? We'll try them both. So let's ping 1.22. And this is going to fail, right? So the thing is, with PC0, it's going to think that it can ARP for 1.22 and good things are going to happen. But really that ARP is going to remain within this broadcast domain here, and it is not going to make its way over to the left-hand side, and therefore it will fail. So hopefully that makes sense. Control C that, and let's just try 21 also. That one's going to fail as well, because the ARP that goes out, the ARP request for that destination IP, because it's on the same subnet, so we'll ARP for that, it's going to fail in its transaction. So that's no good. So even though they are in the same subnet, they are in different VLANs, and therefore, essentially, when we talk about this in virtualization, we call them port groups. They're in different port groups, and if we look at the configuration of the switch, you'll see that if we just do an EN, WN does not work. EN does. Show run. Look what we got here. Interface 1 is VLAN 30. All right, cool. Interface 2 is in VLAN 30. Interface 3 is in VLAN 30. Interface 4, 5, 6, 7, and 8 are all in VLAN 30. So anything connected, as long as they're in the same subnet, as long as they're configured correctly in the same subnet, anything that's in VLAN 30, that's basically a port group. And they're going to be in the same broadcast domain that you've manufactured on this switch, and they're going to be able to communicate. And any interface on the switch that's in a different VLAN, like starting at interface 9, so 9 and 10, 9, 10, 11, 12, everything else is not going to be pingable by VLAN 30. I hope that shines some more light on this. The questions about the lights, who cares? And in terms of collision domains, every device connected to a switch is in its own collision domain. We should have learned that already. And in terms of ports, what are the broadcast domains in the switch? The broadcast domains are the port groups, and they are identified by the different VLANs. And we just saw that when we show the switch configuration. Hopefully this was helpful for this particular lab.